Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad geometric challenge, and here we have a nice circle in which we have the length of CB are 36 and the length of AB are 24. So here the O point be the center of the circle, and our claim is to find the value of the radius of the circle. So here we suppose that this is the center, and you know that the distance from center to any point of the circle is called the radius of the circle. So here you see that this is the radius of the circle because it passes through the center of the circle. So now the very first thing we are going to do is here first we suppose that uh, O be the center of the circle, and here you see that the radius which is we find is OC, and we denote it by R. You see that this OC be the radius of the circle, and we are given that the length of BC, here we have the length of BC is 36, and you focus on BC and you see that the total length BC will be sum of these two lengths. If you just add BO distance and OC distance, then you give the total distance BC. So now here we break our total distance BC as, because you see here BC equals to BO distance plus OC distance, and you see here BC distance is 36 and BO distance is unknown distance. So now first we find BO distance, so we write it as it is, and OC distance is denoted by R. So in this case we will easily get the value of BO distance. It is equals to 36 minus R. So this is the distance of BO. And now here we make a little bit constructions here, and we draw another radius other than OC. So if you join this A point with O, then it is also called the radius of the circle. So here you see that I will just join this A point with O. So you see that this is also the radius of the circle, and here we denote the radius of the circle by R. So it means that this is also radius and we denote it by R. And you see here this distance will be found here, and it is 36 minus R, and because this AB and BC lines are perpendicular to each other, so it makes the angle 90. So now here you focus in right triangle ABO. So this is the our figure, and you see here in ABO right triangle, and you know that the Pythagoras theorem is applied to the right triangle. So here this is the our hypotenuse side, and we call this as base, and this is the perpendicular. So our Pythagoras theorem tells us that hypotenuse square equals to base square plus perpendicular square. And in the diagram you see here our base is BO, perpendicular is AO, and our perpendicular is AB, and our hypotenuse is AO. So we write it here. Our hypotenuse is AO distance square equals to base, and our base is BO distance square, and perpendicular is AB distance square. And now we substitute all the values of AB, all the values of hypotenuse, base and perpendicular in this diagram, and we move towards our final solution. So that here we substitute the values, and you see here the AB distance is 24 and AO distance is R. So we put these values here. AO distance is R, so its square, and it will becomes R square. And we have BO distance. Here you find BO distance, in it is 36 minus R, and here it is square, so it will becomes 36 minus R square. And AB distance, so this is the AB distance and it is 24, so we put. Now we simplify this relation and we find the value of R square. So here in the left hand side we have R square equals to, now we open this square identity, and you know that it is equals to 36 square plus R square minus 2 times of 36 into R, and we have plus 24 and its whole square. So in the next step you see here this R square is cancelled out by this R square, and in the left hand side we get 0 equals to, here we have 36 square and plus 24 square minus, here we have 2 times of 36 times of R. So because here we find the radius of the circle, so here we move this term to the left hand side, and it will becomes 2 times of 36 times of R equals to 36 square plus 24 square. And now we move 2 times of 36 in the right hand side, and we get R equals to 36 square plus, we write 24 square as 24 times of 24, and we divide 2 times of 36 on both of the terms one by one, so you get 2 times of 36, and here you again divide this term by 2 times of 36, and you see here these 36 are cancelled out by this 36, and you get 36 over 2 plus, here you see that this 2 12s are 24, and 12 3s are 36, and you again cancel these terms and you get 3 8s are 24, so you obtain here 8 only, and now you cancel these terms and you get 2 18s are 36, so finally you get 18 plus 8. So here we have the radius of the given circle equals to 26. So this is the our final answer of this problem. And now we move toward the circle and we put the value of the radius here. So this value equals to 26. And this is the final answer of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.